right, here's example 2. Your employer has offered to pay offer 2 pay scales for you to choose from. The first option is to receive a base salary of $250 per week plus 15% of the price of all the merchandise you sell. Second option is represented by the graph. Compare the properties and functions. So first thing you do is write out the equation. So we'll call this, let's see, did they call it anything? Okay, they didn't give it a name, so we're going to call this one g of x. Okay, that's the graph. All right, the next thing I want to look at is, well, what is f of x? Well, the base salary was $250 plus I get 15%, that's 0.15 of all the stuff that I sell, which would be x. So just a basic linear, and we should remember that that's not in slope-intercept form. I wrote it backwards, right? So that should actually be 0.15x plus 250. All right, so that's what we're comparing. We're comparing f of x to g of x. Well, first off, what's my y-intercept? Y-intercept here is 0 to 50. My y-intercept down here is 0 to 100. So basically, if you're comparing the y-intercepts here, in this scenario, the first option is going to pay you a base salary of $250. The second option, given by the graph, is going to pay you a base salary of $200, right? We know that because that's the starting amount. If you don't sell any stuff, you're going to get $200. All right, so what's my slope here? Slope is 0.15. In other words, you get 15% of whatever you sell. All right, let's see if we can figure out what our slope would be on the graph. A little bit tough to see. I see a point here that I can use and a point here that I can use. All right, so the question is, how far up did I go? So what's remember my slope is y2 minus y1 over x2 minus x1. All right, so the first point we have here is 0 to 100. The second point we have here is 500, 300. All right, so x1, y1, x2, y2. All right, so here we go. We would do 300 minus 200 over 500 minus 0. So that would give me 100 over 500, which is 1/5, which is also known as 0.2. So to compare those, I'm getting 0.2, which would as a percent would be 20% of my sales based on that slope that we had there. So 15% of my sales versus 20%. So I have a lower starting amount of 200 for g of x, but it's going up at a faster rate. Now, the question is, which one of these would be a better option? How can we figure that out? Well, what we could do is we could plot these, right? We could graph them, and then go from there. So if you wanted to plot that, you start at 250, okay? And then how could I graph that based on what I have here? Well, 0.15 would be 15 out of 100, okay? So if I were to make that a little bit easier, say we did 10 more than that, multiply by 10, then we go up 150 and right 1,000, okay? So I could do that. You go up 150, so there's up 50, 100, 150, and over to 1,000. That's actually going to pretty quickly show you where the intersection point is, which is kind of nice. That's where they cross. There's my quick sketch. And so what you would see there is that if you were to sell $1,000 worth of stuff, it really wouldn't matter which option you choose. After 1,000, then the graph option, g of x, would be better. Before 1,000, if you sell less than $1,000 worth of stuff, then f of x would be a better choice. Okay, so really just finding ways to compare when you have graphs versus whatever. All right, so We'll move on to the next example now. Alright, so two airplanes are in flight. The function f of x was 400x plus 1200 represents the altitude. So they gave us the equation here for f of x. So let's go ahead and very quickly pull out those key features. So for f of x, we have a y-intercept of 1200. Right? So I should write that as 0.01200. And our slope is 400. Now, f of x is the height of the plane after x minutes. So whenever they started measuring it, this plane was 1,200 feet or whatever off the ground. And then it's going to be increasing by 400 feet. So this plane is still rising, still taking off. Now, if you look at the graph, the second airplane, we'll call it g of x. It is obviously not increasing. So can we figure out some stuff about it? It looks like the initial amount is somewhere between 5,500 and 6,000. So for g of x, it would appear that our y-intercept is at maybe 0, 5, 750. Sure, we'll call that. And then obviously we're decreasing. So let's find two good points. Here's one, here's another, to do our slope. So M for this would be, that's going to be, you can't really see it, scroll down a little bit. 3. Okay. So 3, 5,000. And here was 1, 500. Alright, so we're going to do 5,000 minus 5,500 over 3 minus 1. Sure, I did that. Alright, so we end up with negative 500 over 2, which is negative 250. So this plane is decreasing, right, in altitude by 250 feet per minute, while the other one's increasing. So you could eventually use that to figure out where the two will cross. Hopefully you get the idea with this, but really it's just comparing different types of linear functions, okay? So after you're done with these videos, go ahead and work on Walsh 351, and then move on to videos for 352, which is comparing exponentials.